Hello, my name is Haris Kajtazovic, and I am now a graduate from McEwen University, and I will be presenting about my research called Investigating Virtual Simulation of Optic Lab in Physics Education. Developing technologies have the potential to enhance individuals' everyday lives. One such developing technology is virtual reality, and from that, we're able to make educational virtual reality simulations that can provide another approach to teaching STEM topics. Educational VR applications can implement various learning theories such as constructivism and cognitivism, and more. Benefits of educational VR simulations include an immersive learning environment as well as support student education. On the right, you can see two screenshots from my own educational virtual reality simulation. Top one kind of shows of a tutorial room, allowing the user to get familiarized with the virtual reality environment. And the one below it is the first main activity room. The educational VR application used in this research is an optics-based VR laboratory that explores the laws of reflection, refraction, and the phenomenon known as total internal reflection. The optics-based VR laboratory utilizes 3 rooms, each containing an interactive blackboard where the user would get their educational content from, and a puzzle so that they can apply what they just learned to a practical problem. There's also a tutorial room that helps reduce cognitive load on the user, providing them a space to learn the VR mechanics. The optics-based VR laboratory applies the learning theories mentioned earlier with the idea of providing a better user experience. A pilot study was done previously which yielded positive results, which kind of gave motivation to continue researching the optics-based VR laboratory. Therefore, the optics-based VR laboratory was investigated to determine its usability and effectiveness in conveying the topics covered in the application. The research was conducted in 5 phases. So phase 1 was planning the research, creating the questionnaires for the participants, and reviewing the previous pilot study results. Phase 2 focused on getting ethics approval and minor bug fixes. Phase 3 was primarily participants seeking for the user testing. Phase 4 conducted user testing sessions. Phase 5 was a data analysis from the post-user testing survey. A total of 16 participants that underwent the user testing. All participants completed the optics-based VR laboratory. 11 participants were majoring in computer science, while the other 5 were students of different majors. A total of 5 questions were asked during the post-user testing survey. Each question asked the participant to give a rating from 1 to 7. The questions asked during the post-user testing survey was, the first one was, prior to the experiment, how familiar were you with the physics topic of optics? 1, not familiar, 7, very familiar. We received an average response of 4.38. The second question asked was, overall, how would you rate your experience in the educational virtual reality application? 1 was poor and 7 was excellent. We received an average response of 6. Question 3 asked, overall, how easy was it to navigate the virtual reality application? 1 was difficult and 7 was very easy. The results yielded an average response of 5.75. Question 4 asked, overall, how well would you rate the virtual reality application's ability to explore the topic of optics? 1 was poor and 7 was excellent. We received an average response of 5.8. Question 5 asks, compared to other traditional teaching methods you've experienced in the past, how effective was the virtual reality application in teaching the topic of optics? 1 was poor, 7 was excellent. We received an average response of 6.1. Here we can see the graphs of each question's results. From the results of the user testing, participants had an enjoyable experience going through the optics-based VR application. Participants had an easy time navigating the application, suggesting the tutorial was beneficial. Participants felt like the optics-based VR laboratory effectively explored the concepts in the application, suggesting that the learning theories incorporated in the design and implementation of the activities helped explore the topic better. The user study makes it evident that applying learning theories to educational VR applications can provide a positive outcome. In conclusion, educational VR applications can provide significant benefits for an individual's education. Applying learning theories to the design and implementation of educational VR applications may create a fun yet practical educational experience. Future work/directions that came from this study are larger scale study including 2 groups to compare educational VR applications to conventional teaching methods, and of course creating educational VR applications across other STEM fields. Thank you guys for listening to my presentation. I hope you all enjoyed the conference.